Hi everybody. In this video, we are going to talk about Vieta's theorem, which is very important for solution of quadratic equations. And also we are going to talk about the applications. So first of all, try understand how it works. We are going to talk about the equations or square equations of this form, x squared plus px plus q equals to 0. So you can see what's essential here. The essential part here is that here we have the coefficient of x squared equals to 1. So the Viet theorem is applied when we have here coefficient 1. So in this case, the theorem states that if we have here two roots, x1 and x2, then their product is going to give us q. And the sum of these two numbers, we are going to get as minus p. So p with minus negative sign. So for example, let's do some examples here, trying to understand what is Viet's theorem. So x squared minus, for example, 3x plus 2 equals to 1. Without applying the discriminant or solution formula, we can solve it. So we are looking for two roots. That product will give us 2. So obviously these two numbers can be 2 and 1, yeah? Because their sum also, when we multiply, we are going to get 2. And their sum also, 2 plus 1, we are going to get equal to 3. So 3 here. Obviously, you have to be sure that p here is minus 3. But we are going to take negative 3, so it's going to be 3. Let's do another example. For example, let's suppose we have such an equation, x squared minus 7x plus 10 equals to 0. So in this case, again, the product of two numbers should be 10. These numbers are 5 and 2. And their sum, their product gives us 10. And their sum will be 5 plus 2 is equal to 7, negative of this sign. Let's see another one. And also x squared plus, also let's try to write something with negative signs, plus x squared plus 5x minus 6 equals to 0. So obviously we can have here the product minus 3 2 or minus 2 3, but their sums do not give us negative 5. We should get here negative 5 the sum. So you can tell that it is minus 6 and 1, because when we multiply them we get 6 negative 6, and when we add them we are going to get negative 5. You have to pay again attention to p. P in this equation is 5. However, we are going to take negative p, so it's going to be negative 5. We are interested in negative p here. So that was the basic essence of the Viet's theorem. We are going to do many exercises in our classes related with this to get the skills. However, also if you looked attentively to the topic, our today's purpose is to also talk about the applications of Viet's theorem. So in this regard, I'm going to talk about things which we can solve easily using the Vieta's theorem. So x squared, let's look at this equation. X squared minus 3x plus 1 equals to 0. So we are required here, let's write here problem 1. It's problem, let it be problem 1. So let's suppose we are given such an equation, and we are requested to find such a sum of reciprocal roots. So what does it mean? The reciprocal of roots we add. So we need to get here some number here. First of all, if we look at this equation, when we calculate the discriminant, we are going to get 9 minus 4 equals to 5. So obviously x1 equals to 3 plus under root 5 divided by 2. And x2 equals to 3 minus under root 5 divided by 2. But however, you can see from this expression that we have here a difficulty. So of course, such tests in the exam do not require to find this one. So we are going to forget about it, and we are going to solve it with something different method. So today I'm going to show how we can do it. So let's first bring to common denominator this expression. So the common denominator here is x1 and x2. So it's going to be x1, we have to times x2 here, plus, and here we have to times x1. And this is equal x1 plus x2 divided by x1, x2. So what does it give us? Of course, again, we don't know the rules, but however, we know the Vieta theorem, which we can apply here. So obviously, look here, x1 plus x2, we said that it's, according to the rule, it's 3 divided by, and x1 times x2 is 1. So you can see, according to Vieta theorem, we can easily find this expression. Now let's see another problem. Let's write problem 2. In this problem, we are going to do something, we are required to find something more challenging. Let's take such an equation, x squared minus 5x plus 2 equals to 0. We are given such an equation. Again, with difficult irrational roots, let's try to find such an expression. x1 squared x2 plus x1 x2 squared. So let's calculate this one. So again, looking here in this expression, we can see that there is a complex, it's a composite expression with some roots. And finding the roots and placing here will not work. It will take us a lot of time. But what we can do, we can factor out x1 and x2 here. So what we get here, x1 plus x2. So x1, x2, obviously here, the product of x1, x2, obviously here is 2 times x1 plus x2 is 5. So it's going to be 2 times 5 is going to be 10. Let's see another problem of this type. Let's suppose problem 3. So in this problem, we are going to have again a more difficult case, so which is also common in exams. So suppose we are given x squared plus again 4x minus 1 equals to 0. So let's try to find this expression, the value for this expression, x1 squared plus x2 squared. So before I open this, expand this in brackets, let's remember this formula: a plus b squared equals, a squared plus 2ab plus b squared. So this is the formula for perfect squares. It's known as perfect squares formula. So if we are given a squared plus b squared, obviously to get here this full complete square, we need to add here this term. You see, a squared plus b squared plus 2ab. But also do not forget to subtract this, because, adding things here, non-zero elements, we can change the sum. But if we subtract that element, nothing changes. So 2ab and 2ab, we can cancel, we get the same thing. So nothing changes here. So, however, for us, it works if we take these 3 terms here. So it's going to be a plus b squared minus 2ab. So I'm going to apply the same thing here. So x1 squared plus x2 squared, we add 2ab and we subtract 2ab. So in our case, ab is, let's write directly, 2x1 x2, and we subtract 2x1 x2. So it's going to be these 3 terms together make a complete square of x1 plus x2 minus 2x1 x2. So you can see here that we already have the possibility of application of Vieta theorem, because x1 plus x2 here is -4. So it's going to be negative 4 squared minus 2 times x1 and x2. x1, x2 product of the roots should give us minus 1. So minus 1. So it's going to be 16 plus 2, which makes 18. So this expression is going to be equal to 18. Again, it's going to be 18. So we can, with this method, we can apply different types of questions we can answer. You see, application of Vieta theorem saves us a lot of time. So we don't need to do here too many simplifications with roots. So I would like to add that this theorem and applications are used widely. They are common in exams, especially attestation exams, graduation exams, and also admission exams by our state examination committee. So I wish you good luck with this stuff. If you have any questions, do not forget to write in the comment section or to address to my direct contacts. So hope to meet you in our next videos. Have a good day. Thanks.